Thanks for warm welcome. Good morning to one and all. First of all, I pay my humble tribute to great visionary and founder of Sri Shivaji Education Society, Dr. Panjabrao Alais Bhausaheb Deshmukh. I am thankful to the principal of R.R. Lahoti College, Morshi, and all the members of organizing committee for organizing this wonderful event. Really, this event useful for the students to upgrade their knowledge. I am also thankful to invite me to present my presentation. So thanks to all. I am Dr. Radhika Deshmukh, Assistant Professor, Sri Shivaji Science College, Amravati. My presentation topic is nanotechnology and nanoscience. I want to explain the ideas, synthesis method, characterization and applications of nanotechnology to those who enter in the field of research, particularly nanoscience. Nanoscience or nanotechnology is an interdisciplinary subject. Actually, it is the combination of physics, chemistry, bio, engineering, medical and also Ayurveda. Chemistry plays important role in the synthesis and physics plays important role in the characterization. At the same time, for analysis of nanoparticles, engineering and electronics having an important role. So, what are these nanoparticles? My presentation is on how to work in this interdisciplinary topic of nanotechnology. In the content, we are going to see what is nanotechnology, what is nanoscale, what are the different types of nanoparticles, why nanotechnology is important, synthesis of nanomaterials, characterizations of nanomaterial, applications of nanomaterials and future perspective. So firstly, what is this nanotechnology? Nano means nothing but the size of particles in nanoscale. All of you know 1 nanometer means 10 to the power minus 9 meter. And technology means making use and knowledge of tools, machines and techniques in order to perform a specific function. So combination of nano and technology, that is nothing but there are number of applications of this nanotechnology in this world. Now, why nano is? Nano refers the property with respect to bulk. Nano having two more important properties that are very energetic and active particles. Therefore, wide applications in the field of this nanotechnology. What does nano really means? Then it is observed that nano and bulk there is a difference, and due to size of particles there are different properties, and depend upon that there are different applications. The bulk particle are measured in micron, whereas submicrons having a size 100 to 500 nanometer and nano having size 10 to 100 nanometer, and quantum dots are in between 1 to 10 nanometer. There are picoparticles also, and bulk materials can be changed into nano. There are different properties depend upon the size of particles. Here in this photo it is observed that mountain is having a measurement in kilometer, the child in meter, then ant is in mm, but bacteria are in micro, but sugar molecules having size in nanometer. Nanoscales of particles having different sizes, and depend upon that there are different wide applications. So that here the concept of this nanotechnology was firstly given by the scientist Richard P. Feynman. The scientist firstly explained what is nanotechnology is. The invention of scanning tunneling microscope is in 1981, and the discovery of fluorescence, that is C16, in 1985, and that led to the nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. The bulk materials can be changed into nanomaterials. What is this nanotechnology? Then if you find it particular definition, then it is the design, characterization, production and application of structured devices and systems by control manipulation of size and shape of the nanometer scale, that is atomic, molecular and macromolecular scale, that produces structure, devices and system with at least one novel or superior characteristics or property. Nanoparticles are, we say it is a novel particles. That why we call it as a novel particles, because it having a better properties, more functionality and having a low cost, and therefore we can say these particles are nothing but the novel particles. The concept of nanotechnology is not now. From ancient time, the nanotechnology is in exist. All of you know that there are different paintings on the glass or in the church, that paintings having a coating of nanoparticles. Here in this figure I have shown that these are nothing but nanomaterials having a coating on the surface of glass. That glass stained with nanoparticles, and that is 580 and above. And therefore, I want to tell you that the concept of nanotechnology is not new, it is from ancient time. This is nothing but stained glass of an ancient church, and this painting also having a coating of nanoparticles. Nanotechnology is very old. Firstly, in 1965, ferromagnetic fluids are come into existence, and then the word of nanotechnology is used in 1974, and 1980 quantum dots discovered by the scientist. In this way, one by one, later on carbon nanotubes, then nanowires, and now there are different branches of nanotechnology we have. Now the question is that why we are studying or doing research in this nanotechnology? Why this nanotechnology is important? What is the impact of nanotechnology? As nanotechnology is important because there are wide applications in every field of this nanotechnology. If we observe, then nanotechnology having applications in information technology, then also in the advanced technology, in energy and environment, in aerospace, in medicines, in biotechnology, in every field, nanotechnology having its application, it occupy all the fields and area, and therefore this is essential for everyone to study detail about nanotechnology and to do something new, to do some research in the nanotechnology. Regarding to the classification of nanoparticles, it depends on the crystalline form and chemical composition forms, and these nanoparticles are classified into 0D, 1D, 2D and 3D. D means dimensions. It is observed that number of dimensions of this nanoparticle which are outside the nanoscales. According to in 0 dimensions, nanoparticles, all the dimensions are measured within the nanoscale. That is, no dimension is larger than 100 nanometer. Therefore, it is a 0 dimensional nanoparticles. In 1 dimensional nanoparticles 1D. Why it is 1D? One dimension is outside the nanoscale. This class includes nanotubes, nanorods and nanowires. In two-dimensional nanoparticles, two dimensions are outside the nanoscale. One dimension is only a single or few atomic layers thick. The class exhibit plate-like shapes of include or graphene and other monolayer materials, that is amgenes and black phosphorus and so on. All these are of the two dimensions. The three-dimensional nanoparticles are materials that are not confined to the nanoscale in any dimension, and this class can contain bulk powders, that is dispersions of nanoparticles, bundles of nanowires and nanotubes, as well as multi-nano layers. So, the classification of nanoparticle is in 0D, then 1D, 2D, and also 3D. From this diagram, it is clear that in 0D it is in the nanoscale, in 1D it is more than that, and in 2D there is a layer, and then in 3D it is in 3 dimension, and therefore this is the classification of nanoparticle according to their dimensions. Here it is shown that all the dimensions are at the nanoscale for 0D, for 1D 2 dimensions at the nanoscale, but one is at the nano nanoscale. Then later on 2D 1 dimensions is at the nanoscale and 2 are at the macro scales. In the 3D no dimensions is at the nanoscale, all dimensions are at the micro scales, and therefore this is a diagram for representing the 0D, 1D, 2D and 3-dimensional nanoparticles. Now the question is that how these nanoparticles are forming. According to their shape, that can be heterogeneous and taken on various forms which strongly influence their characteristics. Depending on the production and methods and manufacturing conditions, nanoparticles or material exhibit different forms and structures, that are sphere, needles, tubes, pellets and fibers. Nanoparticles can have different chemical compositions. They can be composed of metals, semiconductor materials, compounds, metal oxides and so on. So in the research and commercial sectors, synthetic nanoparticles are often uh, grouped into the following categories based their chemical and physical characteristics, that is carbonic, metal oxide, semiconductors or metals. So carbonic nanoparticles are fullerences, nanotubes, carbon blacks. But the metal oxides, silicon oxide, titanium oxide, and then aluminum oxide, iron oxide. But in the case of semiconductors, that is cadmium telluride, then silicon, and again indium phosphide and so on. In the case of metals, the nanoparticles of gold, silver, iron and cobalt and so on. What are these carbon nanotubes? Then carbon nanotubes are the allotropies of carbon with cylindrical nanostructures. They have length to diameter ratio up to 132,000 point. Nanotubes are a member of the Fullerene structures family and having a property that is highest strength to weight ratio and helps in creating the lightweight spacecrafts. Now carbon nanotubes may be single layer carbon nanotubes that are called graphene and multi-wall nanotubes, and in this way there are the two types of carbon nanotubes, and this was first designed by the scientist, that is Sumio Lijima, in 1991. Inorganic nanotubes and nanowires are also. Inorganic nanotubes and inorganic fullerenes like materials based on the layer compounds such as molybdenum disulfide were discovered shortly after the carbon nanotubes. And these inorganic nanotubes having excellent tribological properties, resistance to shock wave impact. Nanowires are the ultrafine wires or linear arrays of dots formed by self-assembly. They can be made from the wide range of materials, that is semiconductor nanowires made up of silicon, gallium, nitride and indium phosphide, having demonstrated remark optical, electronic and magnetic characteristics. Therefore, nanowires having potential applications in high density data storage, either as a magnetic read heads or as a pattern storage media. These are the carbon nanotubes which are given here. That is, the applications of carbon nanotubes are Storm Bell spots and then Zytix technology. There are number of applications of carbon nanotubes. Nanorods. Nanorods are the second type of the nanoparticles, that is also called as quantum dots. Nanorods are one morphology of nanoscale objects. The dimensions of these quantum dots is from 1 to 10 nanometer, and they may be synthesized from the metals or semiconducting material. And there are number of applications of these nanorods, that is in display technology and also in cancer therapies. There are number of applications of quantum dots. Nanoparticles of semiconductors were theorized in 1970 and initially created in the early 1980s. Quantum dots are the man-made nanoscale crystals that can be transport electrons. When ultraviolet light hits this semiconducting nanoparticle, they can emit light of various colors, and these artificial semiconducting nanoparticles have found applications in composite solar cells and fluorescent biological labels. So quantum dots now found applications in composite solar cells and fluorescent biological labels. Recent advances in chemistry have resulted in the preparation of monolayer protected high quality monodisperse crystalline quantum dots. Then the next is the nanoboards. What are these nanoboards? Recently the research is going on these nanoboards. This having a scale of 10 to the power minus 9 and largely in R&D phase. These nanoboards of 1.5 nanometers across, capable of counting the specific molecules in chemical sample. There are number of applications of these nanoboards, and these nanoboards having detection of toxic component in the environment. These nanoboards are too much useful. Similarly, in drug delivery and in biomedical instrumentation, these nanoboards are too much useful, and therefore this recently the research is going on these nanoboards. Now we have seen that nanotubes, nanowire, nanoboards, different dimensions of nanoparticle, how nanoparticles are formed, that is the question. How we can synthesize the nanoparticles? There are different methods for synthesis, that is physical, chemical, biological, and hybrid method also, which is the combination of any two, that is physio-chemical and like that. And therefore these different methods are used for synthesizing nanoparticles in the laboratory. So here there is a synthesis of nanoparticle and different methods I have shown. Now in the physical method, there are two physical methods: mechanical physical method, high energy ball, in which include the high energy ball milling methods, and also melt mixing method. The second physical method is a vapor, in which physical vapor deposition, laser ablation, sputter deposition, and electric arc deposition, ion implantations. In the physical method, mechanical forces and evaporation are generally utilized for the synthesis of nanomaterial. So there are three methods out of that. This is about the physical methods. There are also chemical methods for synthesizing nanomaterial, and generally chemical methods are in use. In the laboratory, almost everywhere the working is going to synthesize the nanoparticle by using chemical methods. In that chemical methods, there is a microemulsions method, precipitation method, thermal decomposition, electrochemical, sol gel process, spray pyrolysis, laser pyrolysis, aerosol pyrolysis. These are the different chemical methods. Physical and chemical methods that creates the toxic substances in the environment. So that may be pollute the environment. So in order to avoid that, the biological method, that is green synthesis method, is best. And this green synthesis method include use of microorganisms like fungi or yeast, use of plant extracts or enzymes, use of DNA, membranes or viruses for the synthesis of nanoparticles. Therefore, physical and chemical, rather than physical and chemical, biological method is the best method. So nanomaterials can be synthesized, but there are the two basic strategies for synthesis of nanomaterials, that is top down and bottom up. So top down, the size reduction from bulk materials, and bottom up, material synthesized from atomic level. That is the difference between these two. So nanoparticle synthesis, in which this is the top down approach and bottom approach I have shown in this figure. If you observe, then in the top-down approach, this bulk material is converted into powder. And in bottom-up approach, that atoms are converted into cluster and later on the nanoparticles. So this is about the nanoparticle synthesis. And there are some advantages of top-down approach, and also there are some advantages of bottom-up approach, and also both having some disadvantages also. Now this is the top-down mechanical physical production process. The mechanical physical nanoparticle production process is here, in which there is a milling, and then after milling, then that basic material is again grinding and then fine grinding, and then it will be converted into powder form, and therefore smallest nanoparticles are formed. This method is a top-down mechanical physical production method. The mechanical production approach uses the milling to crush microparticles. This approach is applied in producing metallic and ceramic nanomaterials. For metallic nanoparticles, for example, traditional source material are pulverized using a high energy ball mills, and such mills are equipped with grinding media composed of wolfram and Cambridge or steel. Mining involves thermal stress and is energy intensive. And compared to the chemophysical production process, milling is to crush the particles and yield product powder with relatively broad particle size ranges. This method does not allow full control of particle shape. The synthesis of nanoparticle is top to bottom, that includes mechanical ball bearing, chemical etching, thermal and laser ablation and sputtering. And bottom to top, there are two methods, that is chemical electrochemical and green synthesis. In chemical or electrochemical, that is the precipitation, vapor deposition, atomic or molecular condensation, sol gel process, spray pyrolysis, laser and aerosol pyrolysis. Out of that, generally in the laboratory, whenever we do research of this nanoparticle, then generally sol gel process, spray pyrolysis, laser pyrolysis, these methods, and precipitation method, co-precipitation method, these are used. But in the case of green synthesis, bacteria, plant extract and fungus, from that we can obtain the nanoparticles in the green synthesis. So this is bottom up approach and this one is top down approach. Now bottom up methods are based on physiochemical principles of molecular or atomic self organization. This approach produces selected more complex structures from atoms or molecules, better controlling size, shapes and size ranges. It includes aerosol process and precipitation reactions, sol gel and hydrothermal process. We have to see in detail what are these processes are, as these are using in the laboratory for obtaining nanoparticles. Therefore, aerosol process or spray hydrolysis, flame hydrolysis, that is like this. In the laboratory, the apparatus for this is using in this way. Now, the simple schematic of ultrasonic spray pyrolysis method is given here, and in this case, the sample which is from which we want to obtain the nanoparticles, that is to be obtained by using the top furnace there is, and then precursor solution, and this is about the spray pyrolysis method. Now liquid phase processes consisting precipitation, sol gel and hydrothermal. The wet chemical synthesis of nanoparticle typically take place at lower temperature than the gas phase synthesis. The most important liquid phase process in nanoparticle productions are precipitation, sol gel and hydrothermal. So in precipitation process, the precipitation of solids from metal ion containing solution is one of the most frequently employed production process of nanomaterials. Metal oxides as well as non-oxides or metallic nanoparticles can be produced by this approach. The process is based on reactions of salt and solvents. The precipitating agent is added to the desired particle for precipitations, and the precipitate is filtered out and thermally post-treated. In precipitation, particle size and size distributions and morphology are determined by reaction kinetics and the influencing factor include beyond the concentration of source material, the temperature, pH value of solution, the sequence in which the source materials are added and mixing process. Co-precipitation method, that is refers to obtain an uniform composition in two or more cation homogeneous solution through precipitation reactions, which is one of the important method of synthesis of composite containing two or more kind of metal elements. This method having the advantage of directly obtaining homogeneous nanomaterials with small size and size distributions. This technique is the simplest and convenient chemical pathway to synthesis magnetic nanoparticles. So here there is a precipitation process in which in this figure it is shown that there is a solution which I have prepared firstly, that is ferrous nitrate, and there is nickel nitrate, and these two combinations that are further we heated it, and after that we filter it, and after filtering for drying we keep it in a furnace, and then for annealing again it is heated at about 600 degrees Celsius for 4 hours, and then we will get the powder, and that powder is crushed, and in this way this is the complete precipitation process. This is a schematic diagram of co-precipitation method to synthesize the ferrites, and which is shown here. Second process is the sol-gel process. Sol-gel process is a wet chemical method, the fabrication of both glassy and ceramic materials. In this process, the sol, or it is also called solution, that evolves gradually towards the formation of a gel-like network containing both a liquid phase and the solid phase. It is a gel-like, means combination of liquid and solid. Sol-gel method are widely applied in the preparation of ceramic materials like metal oxides, generally nitrides and carbides. This technique offers advantages over a conventional processing techniques, that is low temperature of reaction, good combination control, good composition control, and high purity level, and ability to developing process for large area applications. Therefore, sol-gel method is the best condensation method, and in which the reaction mainly occurs by hydrolysis and condensation of a precursor. That is, precursor is either inorganic or metal organic, and that resulting in the formation of sol, that is the solution, and after a series of chemical reactions it turns into gel. Means initially you have to prepare a solution and then it will be converted into gel. So this is the sol gel. The gel is like this, which is I have shown. The sol means solution, and after number of chemical reactions then it will be converted into such type of gel. This is sol gel technology. In this sol gel technology, we have taken conical flask, we have taken solution of precursor. Then there is a condensation process, then sol colloidal is formed, then there is a gelation process, then the gel is formed, then there is that gel is dry again, then zero gel is formed, then there is a calcination process, and after that you will get a powder. That powder is pressed in the pellet, and then by sintering final product is obtained, and after obtaining that final product, that its characterization is done by XRD or SEM, or there is RT and magneto RT. Then we can study the properties of that nanoparticle. The third method we generally use is a hydrothermal synthesis. It is also called as the wet method. It is used for the preparation of nanomaterials. It is basically a solution reaction based approach. In hydrothermal synthesis, the formation of nanomaterials can happen in a wide temperature range from room temperature to high temperature. Hydrothermal is a unique method for crystalline substances from high temperature, and therefore hydrothermal method means hydrothermal is of geologic method. Then hydrothermal synthesis can be the method of synthesis of single crystal that depends on solubility of minerals in the water under the high pressure. The crystal growth is formed in the apparatus consisting of steel pressure vessel called as autoclave, and in which the nutrient is supplied along the water. A temperature gradient is maintained, and then this hydrothermal synthesis method gives us the final product. So in this way, here I have shown that the solution which I have taken, and then after that magnetically steering process there will be, then there is a heat treatment, then after washing that sample and after drying it we will get this microflowers. That is, this is the hydrothermal synthesis method. Similarly, this is the second example in which we have taken, that is a calcium phosphate, or this F means fluoride, that is adding, and then NaOH means sodium hydroxide having a pH value 10, then the precipitate is obtained, and then the hydrothermal treatment is given to it, and then after that there is a formation of such type of nanorods. So these are all three chemical methods for synthesizing nanoparticles. So there are physical or chemical methods, that both methods maybe create the toxic substances in the environment. So instead of that, the green synthesis is the best way. Green synthesis of nanoparticles involve the use of plant or plant parts for the bioreduction of metal ions into their elemental form in the size range 1 to 100 nanometer. The process of green synthesis is more efficient, simpler and economical, and easily be scaled up to perform larger operations, physical and chemical approaches of synthesizing nanoparticles. Generation of nanoparticles from green techniques can be scaled up effortlessly, and they are physically smart too. Green methods of synthesis are given here. There may be green synthesis of the nanoparticles of metals in the solution. This metal plus nanoparticle solution can be prepared from the fungi or yeast, or from bacteria, or from plants, that is aloe vera or any plant you may take, and then from algae or other methods that are used here. Now green synthesis, why we use green synthesis? I already told it is a eco-friendly method. It is a biological component itself act as a reducing, and therefore it is reductions the overall cost of synthesis. It is external experimental method and can be used to large scale. Therefore green synthesis is used everywhere, because main part is it is eco-friendly and without any cost. Now in the biological methods, the green synthesis may be from the microorganism by using fungi or yeast, or by using plant extract or enzymes, or by using DNA membranes or viruses. Well-defined structure and available purity of enzymes make them to obtain the green method of synthesis. That is, silver nanoparticles were utilized to be combined by an enzyme induced growth process on strong enzymes were incorporated in polymer multilayer assembled membranes through the electrostatic interaction to develop to the direct and green synthesis of bimetallic, that is iron or palladium particles in membrane domain substrates in the nanoparticle synthesis. Green tree extracts were used to get bimetallic nanoparticles. Green synthesis can also be from the vitamins, that is a green combination of silver and palladium nanospheres, nanowires and nanorods by utilizing vitamin B2. It used as a reducing and capping agent, and this vitamin B2 is used as a reducing agent for synthesis of nanowires and nanorods. This is a unique approach in the field of green technology. Green synthesis by plant extract. This method is now using everywhere, and the advanced techniques are used for extracting the plant. It is a biologically produced metal nanoparticles, and these nanoparticles can be synthesized by flowers, leaves of plants, and whereas the part of plants are thoroughly washed with the help of tap water in this method and sterilized by double distilled water followed by drying at the room temperature. Means this method is very simple. I already told you that the nanoparticles can be synthesized. I told you that by flowers, by leaves and plants. and these which are easily obtained in our environment. And these flower plants or leaves you have to firstly wash, then double washed by distilled water, and followed by drying at the room temperature. Then after that you have to bake that and crush it. Then this plant extract is mixed with the mealy QH2O as per desired concentration and boiled with the continuous stirring. The obtained solution is then filtered with Whatman filter paper, and the part in which there is a clear solution was useful as a sample. So it is a very simple, easily available method, and there are number of antibacterial and medicinal properties in that plant, and therefore we can use it. So synthesis of nanoparticle by plant extract, already I told you procedure. Take the plant's part, then boil and wash with the distilled water, squeeze it and filter, add respective salt solutions, then solutions color will be changed, and as the solution color change, then we came to know there is a formation of particle and then separate it. In this way nanoparticles can be formed, and these nanoparticles formed by this green synthesis method having number of applications. Here we have taken the Artocarpus heterophyllus leaves, that is nothing but all of you know fungus. Extraction of leaves of that Artocarpus heterophyllus leaves. I have taken it, then washing and drying and grinding it, then see heating the aqueous mixture of leaves powder, then filtrate it, and then after that filtrate the aqueous leaf extract is obtained. Then this extract is added in the leaf extract is added in the silver nitrate solution, and then we heat it, then we get the change of the color of solution. See, the color of solution is changed from reddish brown to that blackish color, and the silver nanoparticles suspension, or there is a formation of silver nanoparticle here. And then later on after the formation of silver nanoparticle, then you have to centrifuge that. After centrifugation and drying, we get biomolecule coated silver nanoparticles, and these silver nanoparticles having number of applications in medicinal field and having antibacterial properties. And therefore like this fungus plant means it is also called as Artocarpus heterophyllus. Everyone know that, and from that we can extract this in this way. Similarly here another plant you may take, and then again the same procedure, and from that you can obtain the silver nitrate particle. After obtaining that silver nanoparticle, we have to use the characterization of that particle, and we have to also study the applications. How we characterize the nanoparticles, that we have to see. There are number of methods for studying the characteristics of nanoparticle. The number of methods are like this: Fourier transfer infrared spectroscopy, Raman spectroscopy, photoluminescence method, and actually photoluminescence analysis, transmission electron microscopy, scanning electron microscopy, X-ray diffraction method, then atomic force microscopy. There are different techniques that we use for studying the characteristics of these nanoparticles. So these nanoparticles can be characterized. So here the particles which we have just formed by using the Artocarpus heterophyllus leaves, and we obtain the silver nanoparticles, and then we study its characterization. We want to find out we want to confirm the crystalline nature of this silver nanoparticles. So we have to use the XRD technique here. We get such type of graph, and this diffraction pills at the 20 value shows that it is the face center cubic crystal. We can determine the crystalline size by using this XRD technique. Similarly, we use for biosynthesis of this silver nanoparticle, and in order to study the surface morphology of these particles, that can be monitored by using the field emission scanning electron microscope method, and in this way we get such type of picture. So these obtained silver nanoparticles having a number of applications, that is drug delivery, X-ray imaging, agriculture, drug delivery, and then again photothermal therapy and so on, so that after characterization nanoparticles having number of applications. So these are the applications of nanoparticle which are obtained by using the green synthesis in every field. Now this how we can characterize the nanoparticles. The characterization of nanoparticles in different state, that is generally three ways we can characterize it and study its different means crystal size, its morphology and so on. We use the transmission electron microscope, scanning electron microscope, X-ray diffraction. These three are common, and also you can study its properties by FTIR, then atomic force microscopy, mass spectroscopy, gas absorption and so on. This is the electron microscope, but wavelength of the electron beam is much shorter than the light, resulting in much higher resolution. And this electron microscope may be of the two types, that is transmission electron microscope, that is TEM, and scanning electron microscope, same. Now try to understand. Firstly, you obtain the nanoparticles, you synthesize the nanoparticles, and that obtaining or synthesizing nanoparticles are now you have to study its characteristics, and therefore for characterization you use here TEM and SEM and XRD method. Transmission electron microscope is capable of imaging at significantly higher resolutions than the light microscopes. This enables the instrument to capture the final detail even as small as single column of atoms, which is thousands of times smaller than the resolvable objects seen in a light microscope. Transmission electron microscopy is a major analytical method in physical, chemical and biological sciences. TEMs find applications in cancer research and virology. The parts of the TEM are electron gun, electron column, electromagnetic lens system, detectors, water chilling system, specimen sample chamber, and main control panel and operational controls. Actually, its diagram is like this. This is the transmission electron microscope through which we can characterize our sample. Transmission electron microscope of SARS-CoV-2, this can also we examine under this. We find out the nature and then its morphology of the particle by using this transmission electron microscope. The second one is scanning electron microscope. It can scan and focus electron beam over a surface to create an image. The electrons in the beam interact with the sample, producing various signals that can be used to obtain the information about the surface topography and composition. The scanning electron microscope, this instrument is like this, and then these are the different parts of this instrument, and the main components includes the source electrons, column down which electrons travel with electromagnetic lenses, electron detector, sample chamber, computer and display to view the images. These are the different component of SEM. In this way, SEM and TEM, these are the two electron microscope. SEM is based on scatter electron while TEM is on the transmitted electrons. The sample in the TEM has to be cut thinner, whereas there is no such need with the same sample. SEM allows for large amount of sample to be analyzed at a time, whereas TEM only small amount of sample is to be analyzed. SEM is used for surfaces, powder and polish and each microstructures and IC chips, chemical segregation, whereas the TEM is used for imaging of dislocation, tiny precipitation, grain boundaries and other defect structure in solids. TEM having a more resolution as compared to SEM. So this is these are the two images of the nanofibers. This one is in the optical microscope and second one is by using scanning electron microscope. See the difference, how it is, how resolution will be. The next technique is XRD. All of you know that is X-ray diffractions. This XRD technique or X-ray diffraction is one of the most extensively used technique for characterization of nanoparticle. It provides information regarding the crystalline structure, nature of phase, lattice parameters, crystalline grain size, and advantage of XRD technique. After you are synthesizing the nanoparticle, we have to use this technique, that is XRD. XRD, TEMS, and these are the what common techniques generally for studying the characterization of nanoparticles. The composition of particles can be determined by comparing the position intensity of peaks with the reference pattern available from International Center for Diffraction database. And in this way, after the characterization, we have to study about the innovative applications of this nanotechnology or nanoparticles. There are a number of applications in different fields, I already told you. In energy, in medicine and drugs, and in nanobiotechnology, nano devices, optical engineering, defense security, bioengineering, cosmetics, and nanofabrics. There are a number of applications of nanotechnology. Nanoparticles have a range of potential applications in the short term in a view of cosmetic, textiles, and plants. Nanoparticles can be arranged into layers on surfaces, providing the large surface area, hence enhance the activity. Manufactured nanoparticles are typically not products in their own right, but generally serve as the materials, ingredients, and additive in existing with the products. Nanotechnology having applications in drugs, that is in the treatment of cancer, that provide the new options for drug delivery and drug therapies. Enable drugs to be delivered to precisely the right locations in the body and release drug doses on a schedule for optimal treatment. Therefore, nanotechnology is used in the treatment of cancer. It is also used in the properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to improve the performance. They are used in the electronics. Nanotechnology, nanolithography is used for fabrication of chips. The transistors are made up of nanowires that are assembled on glass or a thin film of flexible plastic. E-paper display or sunglasses and map on the windshields. Nanotechnology is also useful in mobile. Morph, a nanotechnology concept device developed by Nokia Research Center and the University of Cambridge. The Morph will be the super hydrophilic, making is extremely dirt repellent. It will be able to charge itself from available light sources using photovoltaic nanowire glass covering of its surface. Nanotechnology is used in computer also, and there are number of uses of nanotechnology in every field. Already I explained, and silver nanocrystals have been embedded in the bandages to kill the bacteria. Nano particulate based on synthetic bone, and there are some aerosols also, and therefore there are number of applications of this nanotechnology. The applications of number of applications of quantum dots in medicine, in photovoltaics, and in graphene quantum dots are also useful in the that is owing to their unique photoluminescence properties that are also used for photoelectronics and photovoltaics or biosensing. And then perovskite quantum dots are also in use, and then quantum dot TVs and displays, they are also used. In nanoengineering, there is also use of nanotechnology. DNA nanotechnology employs DNA as a programmable building material for self-assembled nanoscale structures with the control structure that can be improved surface property and relevant to biosensing materials, science, and cell biology. Also there is a 3D printing, that is a fabrication of three-dimensional objects through direct deposition of functional materials called as additive manufacturing, that has been the subject of intense study in the area of macro scale and manufacturing for several decades. Applying 3D printer concepts to nanotechnology could bring similar advantages to nanoengineering: speed, less waste, and economic viability than it is expected to bring a manufacturing technology. Applications of nanotechnology in nanoelectronics also. In the field of nanoelectronics, materials like nanofibers that are useful, and carbon nanotubes that having special characteristics, therefore they are used in optoelectronic devices. Nanorobot, that is the invention is going on it. It is nothing but a popular term for molecules with a unique property that enables them to be programmed to carry out a specific task. These nanorobotic manipulation technologies, including the assembly of nanometer sized parts, the manipulation of biological cells or molecules, and the types of robots used to perform these tasks, also form a component of nanorobotics. Due to their size comparable to biological cells, nanorobotics have a vast array and potential applications in fields such as environmental monitoring or medicine. Therefore, it is necessary to work more on the nanorobot. In nanobiotechnology, there are a number of applications of this nanotechnology. Nanosensors are used in agriculture and in food technology also. Nanotechnology is also in cosmetics. The applications of nanotechnology are found to be in cosmetic products. All of you know that is there is a UV filters. The first of this use of nanoparticles as a UV filter. Titanium dioxides and zinc oxides are the main compound used these applications. Air products using nano emulsions to encapsulate active ingredients and carry them deeper into the hair shafts. Pure Ologay, that is nothing but the experimenting with nano emulsions in 200 when the company founders set out to create a product line specially developed for color treated hair. In sunscreens there are zinc and titanium nanoparticles are, and in color science, and also there are number of applications, that is DDF, that is plan more nanotechnology enhance anti-aging products. Therefore nanotechnology is useful in cosmetics. Nanotechnology is also in energy production, that is renewable energy production, and in order to improve its quality. One of my patent I have on this nanotechnology in energy, that is we have made a such type of chip that can accumulate more solar energy, and therefore in order to uh, do some more research or innovative research we can do in this field, that is nanotechnology in energy, that provide essential improvement potentials for the development of both conventional energy sources and renewable energy sources. And therefore nanotechnologies will play a decisive role in particular in the intense use of solar energy through the photovoltaic system. And nanotechnology is also in space, that will play an important role in the future space missions. Nanotechnology concept proposes to utilize electrostatically charged and accelerated nanoparticles as a propellant. Advanced nanomaterials such as newly developed isotopically enriched boron nanotubes could that have a path to future spacecraft, and therefore that can be used to improve the design of satellite also. So this nanotechnology having wide applications in spacecraft and satellite and so on. So there are number of applications of nanotechnology. Nanotechnology also used in food. That is, nanotechnology has a potential to improve food processes that use enzymes to confer nutrition and health benefits. So there are number of applications of nanotechnology in agriculture, in food processing, in food packaging, and in supplements. But as there are wide applications of this nanotechnology in every field, but there are still some challenges and technological constraints. Although it has a great potential to fabricate innovative products and processes in the food sector, there are many hurdles. The major challenge is to produce edible delivery system using economic processing operations with effective formulation for human consumption and safety. The migration and leaching of nanoparticles from packaging materials into food products is to a great concern to ensure the whole of that foods, and then that nanoparticles either directly or indirectly added are sometimes been isolated as a result of migration from the other sources. So the materials behave as entirely different at the nanoscales, and therefore the complete understanding of nanoscale functionalities and toxicities of nanomaterials will further argument to its particular application and safety regulations. the potential for commercialization and future prospects. There have been remarkable advances in the nanotechnology applications in food science and research. Nanotechnology is in the detection of toxins, pathogens, and pesticides and tracking, monitoring than the assure maintenance of food quality. The availability of train nanopowder, that is nanopowder, and cost of analysis and procurement of high-end technical equipment not form the roadblocks of nanotechnology. Therefore, it is necessary to protect the nano components, and more extensive research can be carried out in following the areas of wide applications. Safety aspects and challenge can be taken into consideration simultaneously. The novel ideas of smart packaging, development antigen specific biomarks, and amalgamation of the nanoparticles to prepare the nanocomposite polymeric films are slowly being realized. Extensive research can be carried out for the expansion and industrial applications in future. Nanocomposites are the carbon neutral biodegradable molecules, hence their applications in food packaging material could be harassed in the near future, and therefore nanosilica can be explored for commercial use as a anticipated to become an advanced technology with infinite growth plate in 2050, and therefore we have to do more and more research in the field of nanotechnology, but by considering the safety aspects and challenges. So I want to tell all of you that we have to go ahead in the research of nanotechnology, because in future there are again more and more applications in this field. Furthermore, the carbon nanotubes are being used for incorporating the sensors into packaging materials, mainly for detection of microorganisms, toxic substances, and food spoilage. In-depth research can be carried out for the future packaging materials in smart and intelligent food packaging system. Similarly, in the case of sensors, that is, sensors can detect the spoilage at every stage of food chain, which could be in turn reduce the total food loss and benefiting and food producers, retailers, as well as consumers. Therefore, we have to do such type of research which can avoid and solve all these problems. Nanotechnology having a wide applications, but there are some pitfalls of nanotechnology also. Nanoparticles can get into the body through the skin, lungs, and digestive system, thus creating free radicals that can cause cell damage. Once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. The most dangerous nano application used for military purposes is a nanobomb that contain engineered self-multiplying deadly viruses that can continue to wipe out a community, country, or even civilization. So, there are number of pitfalls of nanotechnology. Nanorobots, because of their replicating behavior, can be big threat for Gryogo. So, we have to use nanotechnology. We have to research in it, but for getting number of applications, there are number of challenges that we have to cross and to do something new and innovative. But with that, we try to remove these pitfalls of nanotechnology. These are the references, and at last I want to clear there are a number of my papers on my Google Scholar account, that is Radhika G. Deshmukh. Then you can search on it, and you will get the way for the research in luminescence and also green synthesis. Thank you.